Dooby 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 doo. Dooby 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 doo. Dooby 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 doo. Yeah, we have sound. We have vision. What we got here? Oh, Windows 32 API. Yes, I remember what we're doing. Oh, error log. Oh dear. Window default. Okay. Error log. The can of worms. Before I start this can of worms, we're gonna have to decide on the approach. I was doing a little bit of research into DirectX and OpenGL, and something I noticed. If I look through these files, we've got something like a main window at 7 kilobytes. We've got graphics at 12 kilobytes. That's the kind of expected amount of code. Yeah, okay, I can agree with that. And then you look at error. 197 kilobytes of code. Why? Simple answer. It's a can of worms. Why has somebody gone to... By the way, that is a real developer who has programmed something and distributed it on the internet. It is MIT licensed, so I am allowed to show it. But it also impressed on me what I was reading about error logging and all the rest of it. Why? Let's have a look at what we've done. We started a file. This file is just going to, at the moment, log an error and panic. It's not going to do anything else. It's not going to do anything special. Can we enlarge this? Yeah, we can. Okay. So, you might think, well, that's all well and good. You've got a way of looking at errors. And we did this at the end of the last stream. Just messing around. Okay. Oh, I've already put it in. Okay. Alright, I've got a link. And we were messing around in here. Just having a look at this error checking business here. Just trying it out to log an error. The problem isn't what we're doing. Well, it is. It's partially what we're doing. But there's your problem. And it's a single word. It says unsafe. We need a definition for unsafe. What that says is that get module handle is unsafe. What does that mean? What it means is that it's external code that we didn't write. And it's also not written in Rust. It's written in C++ or C. Microsoft call it C++, so let's stay with what they tell us. It's written in C++ then, okay? But we haven't looked at that code. We haven't seen that code. We don't know who wrote that code. We don't know how good the programmer was that wrote that code. We have no knowledge whatsoever of what it contains. Yeah, I would make that into a definition of unsafe. Not because I don't trust Microsoft programmers, but because I know from experience that I make mistakes. I'm human. Well, they're humans too. And that's the point. There's an old saying in computer programming, rubbish in, rubbish out. I have no guarantees that any unsafe code will work as expected. So what we're doing really is we're protecting ourselves against, well, what other people have done. And in computer terms, that's called undefined behavior, which again is a separate subject all to itself. How do you define undefined behavior? Well, it's undefined. There you go. Undefined behavior gives you unexpected results. Sometimes people will say, oh, you got a bug in your program. Yeah, that's not a good thing to say. Often what you'll find is the computer will give you whatever you've asked for. It's not a bug. And there's a clue. There is the big clue. What are we really protecting ourselves from is whatever that code has asked for. You can't turn around and say, oh, the unsafe code is buggy. No, it's not. It's doing exactly what it's been told to do. Until you get to the undefined behavior bit, and then we've got a different can of worms to open, and things can happen which aren't asked for. So there's two separate things that we're checking against, and all I'm checking against here is what has been asked for. I'm not checking for undefined behavior. So we're only really half error checking. Well, not even that really, about 20%. But it's enough for my purposes, and I think we're going to keep it simple without diving into all the details of undefined behavior and trying to explain all of that. When you get into that area, I think we're looking at a completely separate stream and a lot of talking. So let's get on with this. Right. So let's get to our logging errors, and let's try and get our simplistic error logging sorted out. Oh, by the way, I got a comment about the blue screen. It's ironic, blue screen of death. Yeah, it's, well, something that happens. It's the default value of VS Code. And if you're wondering about my Visual Studio, All I did was switch that over to copy whatever VS Code default value was. So this blue background and everything is default value. I didn't choose it. It's just what you're given. I didn't want to change it because then I'd have to explain how to change it. And, well, that's up to you. You're using the program. If you don't like the blue, change it. As for me, we're doing simplistic stuff, so I haven't done so. Right, to do. Report error in a message window. The user may not have a command line available. We talked about that because Windows, when you execute a program in Windows, you don't get a command line. Ooh. There's no command line for this lovely browser. So if this lovely browser wants to report an error to me, it can't do it using the command line, which we've done here. It has to open a message box. Okay, control click on that link. Message box EX extended wide. Okay. There's its syntax. Alright, we've got some parameters. We've got the handle to the window. Some text. The message to be displayed. This is given to us by the API. It can't create a window for us, but it can create a message box. That's nice. What else have we got here? The dialog box title. So, if this parameter is null, the default title error is used. Oh, so we can null that. Nice. We've got a uint, the contents and behavior of the dialog box. For information on supported flags, see message box. Okay, we will do. Then we've got the language ID, which is 0, which means the language that we're using on Windows. So that's okay. We've got a return value. If a message box has a cancel button, the function returns, yeah, the cancel value. Escape key or cancel button is selected, so it's actually got an escape key out of it as well. If the message box has no cancel button, pressing escape will have no effect. Okay. Unless an MBOK button is present. Displayed, the user presses escape, the return value will be ID OK. Alright, we don't need the return value. And we've got to get last error, otherwise we'll just be running around the errors, won't we? Okay. Alright, I'm up for this. Remarks, requirements, here we go, library, user 32.lib. Okay, we know where it's going. Alright, that could be interesting. Let's go over to user 32.lib. And I think we'll insert ourselves a message box. Let's do that. So we've got a public function. I'm not going to do this in a good way to start off with. Message box EXEW, that's the one, thank you. We do have a hwind. There we go. That's just going to be hwind. What else do we have here? LP text. Okay, we'll have that. That's an LPCW, so long pointer, constant, wide, string. Okay, LP. We do have one. This is a little easier than it used to be. I'm quite happy with that idea. LP caption. Okay, we'll take one of those. That's another one of these LP thingies. Lovely. A U type, which we have to look up. Make sure that I'm copying this properly from the, that's a uint. Yeah, we have one of those. Hey, we're good. You see how we're not having to add types as much now? I like that idea. And W language ID. Okay. Language. Does that look right? I don't know. ID. And that's just a word. Okay. What does this give rise to? An int. Alright, we'll take it as a cint. Okay. Because it's in C. And that should do it, according to that. Alrighty. We do need to have a look at these lovely, lovely things. So we have to go to message box, and we should find a list of these thingies. Oh, we do have a list of these thingies. The message box contains one push button. Okay, this is the default. So we can just put a 0 in. So this is just a load of zeros, isn't it? We just throw up the text and pop a load of zeros in. Is it blocking? Displays a set of buttons and a brief application such as state. The message box returns an integer value that indicates which button the user clicked. It doesn't say it's blocking. Oh. Gives us the parameters. Icon. Okay. Modality. Okay. Return value. Oh my god, there's a lot of information here. Okay, icons. Alright. Requirements. Yeah. Alright. Interesting. Okay. We'll keep it simple. Don't want to dig too deep at this stage. Alright, so we've got some syntax here. How shall we do this? I think what we shall do is just call it and see what happens. That could be an interesting idea. So we need a H-wind. Oh. We need a handle to the window. Ah. Okay. Yeah. So we need H-wind. And that was a H-wind. Alright. Which of course we don't have. So we'll take that. Fine. Hope we got that. Well, we'll soon find out, won't we? That's a bit awkward, really. Alright, we'll go with it. We'll go with it. H-wind. Comma. The text, which is message. Ah, no, it's not. It's an LP text. We're gonna have to modify that. Now we've got a problem. We need a handle to the window. And we can't give one. What can we give? A handle to the owner window of the message box to be created. If this parameter is null, the message box has no owner. That'll do. So we don't actually need it. We can null that. Huh. Alright, how are we nulling things? We're using a core pointer, aren't we? Alright. So we can't do that. That's the first thing. So let's not. That becomes that. Alright. Okay, our next thing is, oh yes, the message. Oops. So we're gonna need a wide null message. Okay. Let's try it. This mightn't be complete. Well, it could be completely wrong. A wide null message. Okay. No, I want the whole thing. Okay, we don't have that. Alrighty. Caption 0. Oh no. Hold. Get the right things. The dialog box, null again. So we're just constructing it now. Okay. I'm doing exactly what it tells me to. And a uint that we said could be 0, didn't we? Yeah, 0. Okay. And it's saying no. Oh, that's an unsafe box. Isn't it? Yeah. Now what's wrong with that? Argument number 1, mute standard, FFI, C void is missing. Expected a U16, found a vector of U16. Alright. So it's not taking in a pointer. I'm not sure I want to put a reference there. I knew I was going to have difficulties with this. Star mute, standard FFI to a C void. Yeah, we've been there before. Is missing. It'll be under types. I'm looking to see if I need to put some use thingies in here. Got a feeling that that's useful. Ba-ba-ba-bum. Pop you in. Alright, that seems to have cleared that out. This function takes 5 arguments, but 4 arguments were supplied. One, two, three, 4. That's message box. That's the wrong thing. A U-type. Ah, right. We missed the language thingy, didn't we? I see. Comma 0. Alright, now what's wrong with you? Arguments to this function are incorrect. Unexpected argument number 2 of type yeah. Argument number 1 of type blah 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 is missing. How do we get past the vec U16? When it wants a standard operating system string of type *const U16. That makes sense. How do we get that? So I've typed in wide null and I've just put message in, haven't I? Okay. So I would need a const star new reference unknown. Okay. Don't think we like this const business. That just gives us a reference to it. There it is. That gives us a block of, that gives us a slice of U16. It's null terminated, I hope. Okay. It's still not really liking it. If you're in C, you'd do it that way round. But I don't think we can. We can't const it there. Okay. That would have to be a U16. Not liking it, are you? Okay. The size of value of type U16 cannot be known at compilation time. Ah. Alright. I've got a feeling there's a way around this in the standard library. Maybe I'm going around about this the wrong way. Because we don't know what the size of the message is, and it's telling us that this isn't a good idea. I completely agree with it, unfortunately. So this message box is going to give us problems when converting to Rust with this message. I think we can get away with the rest of it. Maybe? What is that converting to? We've been able to get away with this before. And we've been able to get away with this before, but now it's become very specific in how it wants to handle it. Okay. As U32. Well, it wants U16, doesn't it? Okay. I see. We just put as pointer. Just get rid of you a second. Mutable, no. He wants constant. Okay, we'll get rid of that one. So this thing. Expected a raw pointer, found raw pointer const. Oh, it's mute. It's mutable. Oh. It says it works. How much do we trust that one? Let me just break it down so people can see what I've done. So that's what I've placed in. Don't put a comma in, do we? Maybe we do. It's always difficult to tell with Rust. You're not asking me for this FFI thingy, okay. Alright, okay. You tell me you can find everything with that. I'm going to check Clippy. Because I've just made this rubbish up. Yes, I know. Don't look at that. Just don't look at the top bit. Quick, clear the screen. Yes, I was messing around with key input. And Little bit of foreshadowing, maybe. But yeah. It's telling me I've got this right. I'm not so certain. I'm trying to keep this as simple as possible. Alright, let's create an error. So we'll take out the handle instance and we'll put in an error. And I have no ideas if this is going to crash. No ideas at all. So Clippy should say, yeah, we've just created an error. That's fine. Error. Could not get the instance handle. Alright. Oh, we've got something. And then it crashes. Yeah, that's right. So it is blocking. It's not a very good output though, is it? Doesn't give us as much information. Huh. Which means when we're logging our error, we should really not be formatting this string here, should we? We should pre-format our message. Saving data. We don't actually do a format here. We just use this thing, which is formatting. Alright. It's FMT is what I'm thinking about. I think we can use it. String manipulations, FMT. And you're using format pling. I'm not sure I want to use format pling, which is a macro. Can we not just use FMT itself? To give us something slightly more simple. They really do like the macros, don't they? Alright, that's your print line macro. This looks awful. You got traits, yeah. Function, format, blah, blah, blah. Right. You need a formatter? Uh-huh. Really? I see, though. I don't think that's the simplest way you can do it either. Okay. Takes an argument, struct, and returns a resulting formatted string. Mm-hmm. And we don't have FMT as a separate thing. We can append. We're getting, again, my string manipulation within the language of Rust is not good. I'm not okay with it yet. So what I'm thinking at this stage is leave alone and come back to that if we really need it. We are getting a message though. So this is working, and that's really what I wanted. So rather than diving into string manipulation and putting a decent message string together, okay, we'll remove that, but I'm going to leave the to-do in. Improve the message output. I think I'm going to leave it as that. Because that message output isn't the best. But it's simple, it's straightforward. We're throwing in what we think we should throw in. Yeah. And it's giving us a simple message box. Now that's pretty interesting that the Windows 32 API gives us this straightforward way of doing it, but not for opening a window. And I know why now. Oh boy, do I know why. But we've now got logging of errors. Okay, and we've got a window output, which is good. To do, remove this code. Yeah, okay. Bye. Tested. We think it's working okay. Alright. I don't mind thinking that things work. So give our class a name. We're okay there. So we now have this error check. So anywhere that there is unsafe code, we really should be checking for errors. Even when it may not be unsafe. Because it's not telling us that this is unsafe. Register window class. Ah, yes it is. So it's here. If you are dealing with unsafe code, this is the best way to deal with it. Separate it out. In fact, I would probably make a new file called unsafe and put all of these functions that are unsafe into that file and then call them from here so there's no unsafe code within the Windows RS. That would probably be a better idea. Alright, we're going to need to know what it's returning. I think it's just a 0, isn't it? Register class EXW. Alright. Not going to find it in here, am I? Okay. Where will I find register class EXW? Because we're inside dialog boxes. Let's go. To here. Let's go back to our tutorial. If it can load it. And try and look it up. It's in Windows and Messages. I believe. Register. Da, 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 da. There it is. Return value is an atom. If the function succeeds, the return value is a class atom that uniquely identifies the class being registered. This atom, or atomic value, can only be used by the create window, blah 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 blah. If the function fails, the return value is 0. Okay. So we need a return value. Let's use 16, which sounds okay. So atom is equal to 0. And all we need to do is change the message. Could not register a window class. So to check this, to make sure that everything works nicely, what we're just going to do is set atom to 0. And we needed a, what was it? A U16? Yeah. Okay. So could not register the window class. Right, that's now giving us a load of warnings, dead code, blah, 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 because we're blocking everything with a... Yeah, could not register the window class. It panics, gives us the error code, tells us where it was. Lovely. Yeah, I think the error system is, well, basic. Very, very basic. But there you go. We now have a log error panic. Okay, so that's that one done. We can get rid of all of this rubbish now. That's all done for us. That cleans up nicely. And basically we've done the whole of that part. Am I happy with that? No, not really, but it's close as we need for now. Okay, we're creating a window. Alright, this is an is null thing. So let's do that. So we can do that. So it's just HWND is null. And I know that's correct. Could not create the window handle. Could not create the window handle. There we go. And that's all we need to put in. So you're done. Display the window on screen. Again, we've got unsafe code. Update the window, unsafe code. That sends a bool back. We have to ignore that one because it does. That's optional. Show window. That does return a bool. Is it in here? It is. What is that return value in truth? This parameter is ignored the first time an application calls show window. Oh, great. The program that launched the application provides, yeah. Otherwise, the first time show window is called, the value should be the value obtained by the main window function in its, yeah, which we've done. In subsequent calls, the parameter can be one of the following values. All right. If the window was previously visible, the return value is non-zero. If the window was previously hidden, the return value is 0. So the return value isn't an error. There's no error return. We're done. Okay. I wasn't quite expecting it to be that smooth. I'm a bit dubious about what I've done, but hey ho, it's okay. What else have we got? We have an error on peak message, don't we? Isn't that -1 for the error? I think I might be right. We are using peak message W. Oh. It says it's a bool, but a bool is an int in Windows 32 API. Huh. Okay. You don't tell us here. That's interesting. Now I know that it gives an error. Or it can. But according to this, it doesn't. Unless we can find something in here that says it does. Ah, here we go. No. It's not that one. That's about threading. And there's only the two types. That's interesting. According to this, it can't give an error. Do we trust the manual? I'll be honest, I don't trust the manual. Oh, that's awful to say. I'll tell you what, though. I think we're going to check for it. I think we're going to check for it. But I don't want to panic. Do I? So all I'm going to do is duplicate. And that tells me that there are better ways of doing it already. So I want to do that. Alright. So I'm thinking along those lines. So we can't use panic here. So what I'm going to do is I'm just going to do a print line. Instead. That will still stop the program. Okay. I'm going to put a check in. It's going to mess the program up totally if it happens. Is that good or bad? And it would have to go in this slot here. Really? Alright. So really what I'm looking at is that. That's what I believe. It's not a panic. What's wrong with you? Cannot find a log error in this scope. I just asked you to do it. Quick fix. Import log error. Alright, we'll go with that. I don't think it likes it. I found a module log error. Ah. Alright. Use log error. Yeah, okay. Super. Log error. I see, we called it the same thing, didn't we? That's why. Bad. You can see how that can cause problems. Not happy with that line, but anyway. Everything looks okay there. I don't want to set this one off. Alright. Alright, okay. That one's okay. That's okay. I think we've got a basic error logging. This needs to be refactored. because we're doing the same thing twice, but we're not. So what we need is this middle bit refactoring out. Okay, that's absolutely fine. I'm okay with what we've got for this point in the code. You can see now that as soon as you go into error messaging, even the basics, well, it's not complicated. The basics isn't complicated, it's just printing out in the whatever style you want an error. Gets more complicated than that, but hey ho, we're not too worried about making it complicated right now. I think I'm going to go with that. We are panicking when we want to. And we seem to be okay. I get a bit tired of this going up here. But everything's alright. Everything seems to be basic error. So we've now got basic error logging. I'll say that's complete. It isn't, but it's as complete as I want to do it. Yeah. We'll go with that. We'll go with it. It's just good to have. Let's have a look and see if there's anything that I've totally missed. Okay. Got the improved message, yeah. Duplicated. Alright, so I've put that in here, so we've done that one. Alright. Peak message W. Check the return value. Yeah, we did that. Okay. Translate message returns non-zero for keyboard messages. I don't think that matters. I don't think that matters at this stage. So I'll take that out. Check doc return. Oh, begin paint, end paint, and fill rectangle. We haven't done that. And destroy window. We can't check that with a panic. Destroy window. Oh. Whereabouts is that? What exactly does that mean? This is a function. Okay. Destroy window also destroys modeless dialog boxes. Okay. If the function succeeds, the return value is non-zero. If the function fails, the return value is 0. Yeah, we should be doing that. So destroy window. We haven't done. Where do we use it? We use it in events. Yeah, we do. So we can't call our error handle. We would have to put in a full error handling routine here. For what reason would it not be able to destroy the window? Because it doesn't exist. We're already guaranteeing that it does exist. We're stopping the program from running if it doesn't exist. Up to a point. I think we're going to ignore that one. I don't mind that one erroring, because that's really on a shutdown. But it's not good to have a shutdown, is it? It could cause a memory leak. I mean, the moon and the stars would have to align for that to happen. But we're not guaranteeing a safe shutdown if we don't check it. I think we'll put a simple solution in then. Just to notify us if the moon and the stars do align when we're developing, rather than anywhere else. I don't think a message box is required on a shutdown. Well, it is. Why am I hesitating? Well, we are inside window procedure, and one of the rules of window procedure is less code the better. Simple as. And sticking a message box in there that blocks can't really do that. You can't have any blocking code in here. You have to remember, this is outside of our code. Right. So we can't block. That's a big no-no. So we won't. This is giving back the good old bull. Yeah, let something. What do we call it? Okay, dyslexia's kicking in. Two C's. Two C's. Okay. Yeah, that's right. Can I find tuple struct or tuple variant? So, what are you on about? Alright, yeah, I think you're just way behind what I'm doing. Thanks. Is equal to return value of 0. All we're going to do is print a line, because we're going to be a bit lazy about this one. And we're just going to put in failed to destroy the window. I'm just going to plonk that in for ease of use. So at least we're checking it. And if that ever comes up, I'm going to just be stunned and sit there completely quietly for about half an hour and think to myself, what the hell just happened? Don't put, no, don't do it. Got it. It should never, ever run that code. Again, it should never, ever run that code either. I'm going to put a note on it. I haven't put notes in here, you might have noticed. Because I'm not certain that we've completed everything. Alright, we now have code with error checking in. we have done something with it, so let's get rid of that. Check docs on return values for the next 3 functions. Begin paint, end paint, and fill a rectangle. We do have a bool in the middle. Okay. Give me a sec. Need to think. Oh dear. Okay. Just a mini biological break. Sorry about that. Alright. Begin paint. It's not in here. Fill rectangle. No, it's definitely not in here. Okay. Looking good though. Create a window. Alright. Let's try and find this stuff. Painting the window. It's in Windows GDI, WinUser.h. Okay. So, Begin Paint has a HDC, handled to a device context, which is obviously the window. Oh, by the way, I've checked our code and it doesn't use the graphics processor. So my GPU is safe. My CPU isn't quite safe running this code. It doesn't overheat though. I did check it through. If the function succeeds, the return value is the handle to the display device. Context for the specified window. If the function fails, the return value is null, indicating that no display device context is available. And this is in our events, isn't it? Again. All right. I think that this will never run either. So if HDC is null, we're just going to do another print line, aren't we? We can't do anything in here. One of the disadvantages of having this thing completely locked off from our main code. So this is WM Paint. Okay. Oh. Bad. Copy paste error. And what do we want to put in here? May as well use the manual for something. Alright. So that's WM Paint. End Paint. Let's have a quick look at that one. Oh, that was Begin Paint, wasn't it? It's not in here, is it? No. There's End Paint. Let's just hop over. The return value is always non-zero. At this point, do I want to break fill rectangle? Don't know. If it is null, what's going to happen? We're not going to be able to fill this rectangle, are we? Painting and drawing functions. There's no fill rectangle, is there? Oh, okay. You've got it here. Ah, there we go. Fill rect is in. It is in here. Oh god. If the function succeeds, the return value is non-zero. If the function fails, the return value is 0. Okay. So this is just a 0 check. Which we do. Well, it'll error out on that one, won't it? It's another one of those. Let success equal whatever. An I32. That's okay. So it is a 0. We just repeat that line. WM Paint. Okay. Failed to paint the rectangle. I can't really think of too much else we could do. Under those situations. Again, this is stuff that should never ever run, but could. Right. I haven't got anything for def prop window. All right. Done that one. Okay. Have I got any more strange notes in here? No, we haven't. Def prop window. Huh. Do. Doesn't. Ah, here we go. Is there an error on here? Depends on the message. Great. Okay. Which one are we using? This one. It just gives us the same thing, doesn't it? Not really saying much about that, is it? That's okay. Right. I think we're down to 2 to-dos on the message output. Because it's a duplication of to-dos. Okay. I'm not honestly bothered about that. That's just code efficiency. Alright. That's where we're up to after doing a little bit of error checking. And you can see that I've been very, very careful about how I've checked the errors. But at the end of the day, we haven't gone deep enough into it. So that is now done. So we've got basic error logging complete, and now we have... I wouldn't say we've error checked the whole code. What actually have we done? So checked errors for the API Win32 API lib functions. Yeah. Alright, we'll do that. And that gives us a clean slate that we can go back to. Okay. Do I need events? Probably not. Window default. What do I mean? Window default behavior. Now, for the last session or so, I've had some notes lying around. And it's all here on this wind class EXW. And I've made the notes more concise. But these notes are quite important. We have things that we are just passing through null pointers at, like this H brush. We know how to do that. We don't need to pass a null pointer through here. This is your window behavior, your default window behavior. And currently our window is our default behavior. We haven't defined it all. We've only put little bits and pieces in there. I think that's okay. But we could do better. So I thought I'd revisit this and see if we could actually do anything with it. Especially this line here, where we have just passed in a null pointer for loading the cursor, the handle to the cursor, which means that our window doesn't know about, well, the mouse pointer, what to do with it. We have no default behavior for it. And it's saying here, load cursor, null pointer, IDC arrow. Well, the DC is usually a device context. IDI. Wonder what this means. Maybe we'll find out as we go. This H brush color window. If we remember, we had to use that in events, didn't we? This H brush thing. Here. So what we could do is try that out. Right, well that doesn't work. Quick fix. Try adding a comma. Pardon? Yeah, that's a good idea. I like it when it has good ideas. Would that work? Would it make a difference? Shouldn't. No, doesn't make a difference whatsoever. Good. Think I'll come back to that one. But we're no longer passing a null pointer in. To me, that's a good start. What else we got? It's this load cursor business. Let me just show you that. So, if we're inside the window, look at what my mouse pointer is. It doesn't change. We've got arrows, we get whatever that is. So as soon as we touch the window boundary, it changes over to the resize icon, and it never changes again. It doesn't know about it. What we could do is pick up on that inside of the window procedure. What I would like it to do, though, is give it a set of cursors to deal with. Or give it something. I'm not sure that's right. Let's look at load cursor. Where will we find that? Oh. Will we find it in here? I doubt it. I doubt it very much, but we'll have a look anyway. No. Alright, what we got in here? Alright, we just got that, have we? That's in dialog boxes. Resources. It could be. There are just so many of these. Load cursor. Load cursor from file. Load cursor W. Oh. Ooh. Loads a specified cursor resource from the executable file. So creates cursor based on data contained in a file. We are the executable file. Ah, hold on a minute. Is there no base load cursor? Creating a cursor. Yeah, they're just using load cursor. Which comes through to load cursor A. Interesting. Alright, now I'm getting suspicious that load cursor is the same as we'll put it through to the others. Where are you getting IDC? Oh, I see. Huh. Okay. Let's have a look at this. Load specified cursor resource from the executable file associated with an application instance, which makes sense. We have the H instance. Okay. And a cursor name. Yeah, we've got the get module handle. We've done that. Handle to the module of either DLL, yeah, that contains the cursor to be loaded. For more information, to load a predefined system cursor, set this parameter to null. Alright, so we're going to put a null pointer in. Alright. If H instance is non-null, LP cursor name specifies the cursor resource either by the name or ordinal, yeah. This ordinal must be packaged by that, which we don't have. If H is null, LP cursor name specifies the identifier that begins with the IDC prefix. Predefined system cursor to load, which is what we want. It's in user32.lib. IDC prefix. Three two five one two. Okay. Is that the first one? It is. Oh my god, there's a few. Append cursor. Ooh. Number of additional cursors are also available that do not have identifiers defined in WinUser.h or are considered obsolete. Oh. Arrows and things. See guidelines for information on using standard cursors. An application replaces a default image by using set. Okay. And then it's talking about icons. I'm talking about cursors and you're talking about icons. Okay. Alright. So 32512 is the magic number. I wonder if that would work. Huh. Alright, so it's this one, isn't it? IDC arrow is an LPCW, a long pointer, constant word string. I've had to do a make int resource W for this because of this resource thingy. Now, what exactly is that? That's a function that I've invented, I think. Yeah. Let's pop it in. So what is it actually doing? And why aren't these working? Yeah, okay. So we need an LPWSTR, an LPWSTR, and a U-long pointer. Okay. An LPWSTR, we'll have one of those. And a U-long pointer, we'll have one of those. Excellent. So I'm hoping now you'll stop complaining at me, yeah. This is just a conversion to allow us to use this in whichever way we want, I guess. Alright, oops. Okay, so we've got that working. This is just a bit of stupidity, really, that's going on, where we're making it available in different types. So we're casting from a word to whatever it wants, or whatever we have, we're casting it to a word. It's basically going to take on all these formats. Variable formats. It's used in different ways in different places. I get you. We'll see how that works out. It could just break and fail. But we do have the type now. Okay. We got the right number, didn't we? 32512, yes we did. Okay. What about this? Load cursor W. It's a H cursor. What's a H cursor? Type. We do have it. It's the same as an icon, which is a handle. Okay. Fine, fine, fine. All quite normal. So what we're going to do, I'm going to put this one in into user 32. Okay. So user 32, just go down to the bottom, I guess. We've got a public function, and this is load cursor W. It's coming up with cursor. We'll put a W on the end because we can. In optional. Optional? Oh yes, of course it is, yeah. Because we're going to be putting a null pointer in there. So, H instance. And that is just a H instance. Okay. LP cursor name. Long pointer cursor name. I love the way they name everything in here. And that's going to be an LP CWSTR. And we're going out with a H cursor. So I've got a return value. So here I don't think that's mutable. Huh. We're going to use this if we can. How are we going to use? Oh, it's a pointer. Whose pointer? Are we going to get away with putting it in here? We're not, are we? We're not going to get away with putting it in here. Because there's a null check. So what we're looking for here is load the system cursor. And it's the operating system cursor that we're at. Yeah. The operating system default. Mouse pointer. Alright. So what we're going to do is let cursor equal this. Now we can put in a null pointer. Okay, so we've got a standard pointer. I'm just going to go with a straightforward null. Okay. We'll try that. And then we're going to go with the IDC arrow, aren't we? Okay. What problems does that give us? Function is unsafe. That means we need to check it. And it's telling me that we're alright. Yeah, that works out. That works out. Okay, it's not liking this now. Okay, so we do need mute. Alright. I would prefer it if we didn't. And we're looking for a null. And what was this? Could not... to extend information. Okay, it's just a fail. Could not get... could not load the system cursor. Okay. I'm going to put that in because this time I'm not confident in what we're doing here. And now it's helpful. Well, that seems okay. Do we think it's going to work? No. If that does work, that has got to be the simplest solution to something that I've ever seen. And we can see now that this window class is starting to fill up a little. Huh. Just note that as an error check. Just makes these very easy to hunt down later in case I need to. I'm not sure I do, but I guess we'll find out. It worked. My mouse pointer's now a pointer. I notice it doesn't work on this. Look at what happens. You have to move the mouse to get it to go to an arrow. Huh. That was interesting. So this program given to us by Microsoft doesn't work exactly right. I'm coming from the arrow there. Yeah. If we use that, it goes back to the arrow. And it goes straight back into the arrow as soon as we hover over. Huh. Solved. Okay. I wasn't expecting that. I was expecting it to say, you got to do it in the Windows procedure. I didn't think it would start doing things automatically. One of the things you might have noticed is that I keep moving the window every time it comes up. But I don't think I have to. This colour window thing is bothering me. That's the default colour, not the system colour. My system is set to dark mode. but it's only asking about the background. What do I want to do about icons? Nothing. What's this? Menu name. I don't really want to do anything about that. We haven't got a menu because we'll put a null pointer in there, so yeah, get rid. We're not doing that one. That's fine. So there's just the icons. I don't have an icon for this experiment, so to that one. I don't think it's giving us an icon, is it? Oh, it is. It's giving us the default icons. Okay. So that's not fantastic. CSH, yeah, this, we should be doing this. As this tells the default behavior to paint when we are expanding the window in the horizontal and the vertical. So it gives out paint messages. Until we get to graphics, does that matter? Not really. That. Okay. Yeah. The window background colour. Who controls it, really? Is it the paint struct? I don't think the rectangle has anything to do with this. I don't know, we'll click on it anyway. No. So not the paint struct. Creating coloured pens and brushes. Colour refs. Yeah. RGB, okay. Why is... There's just no table. Is there a reference here? stock object. Oh, I see. This palette consists of the static colours in the system palette. Ah, but that won't be dark mode, will it? Probably. I don't think this is really worth looking at. GDI, no. Okay. I'm not going into this rabbit hole, I don't think. I've got a feeling that I'm going to be hunting around the wrong thing. Okay, we'll drop that one for now. Anything else I want to do here? Yes, there is. X and Y is the position at which it creates the window on the screen, and we've got CW use default. I wonder if there is a CW centered. Huh. Let's access Visual Studio. Why not? So, that's an error, isn't it? So, let's just go above the error. CW underscore default use default. Is there a centered? There isn't, is there? Alright. And my sound's knocked off. So, is the sound in? Oh, it's Mad Doctor. Oh no, not again. So we've still got that little crackling, have we? I wonder if it is to do with the sound. Just refresh that. Alright, so my sound system should be back on now. And the microphone might be overlaying onto the sound system that's doing a bit of dodginess. I wonder if I can find a table of these. Interesting. What causes that? Da 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 da. Get that's on the dialogue. I'm not sure that I want to go that far. but I'm willing to look at it. Constant variables, yes they are. But you can define your own x and y. Yeah, get client rectangle, rectangle left, rectangle top. Yeah. And then put in your rect. Yeah, well, that's what I was expecting you to say. There isn't a CW for it. Okay. That's fine, so we're not going to do that. I don't mind. If it doesn't exist, then we're not using it. So we are going to just use that for now. I think I've checked most of the behavior. The only thing we haven't got now is our load icon. Huh. And where is this hidden? Create icon, icons, load image, yeah. Okay. This doesn't look straightforward. So it's in there. According to this thing, it's in here. Dee. Yeah. It is. All right. So it just needs an icon name. And it's another one of these LPCWSTR thingies, as is the load cursor. Okay. System icon, set this parameter to null, so it works in the same way. Interesting. I'll have to check through my sound systems again. I thought I'd fixed them. Let's have a look at this. Icon resources, yeah. If it's null, specifies the identifier beginning with IDI prefix. What is the IDI prefix? Okay. Alright, it's this thing. So it's just IDI application 32512. Oh God, you can see where this is going, can't you, already? So we've just done loading up the cursor, the mouse pointer. 32512, doesn't that sound familiar? 32512. It's exactly the same. It's a default. So 32512 is a default value. It's exactly the same All they've done is changed its name. So they're not calling it IDC Arrow anymore. They're now calling it IDI Application. Oh, you've got to love this stuff. So all they did was change the name. And it's still an LP CWSTR. Oh, it isn't. Hold on a minute. Yes, it is. So why is this different? That's an error in the manual. That's a typo. It's got to be a typo. Because we're using the wired version. Yes. Well, that's a bit of a surprise. Okay. I'm going to put it in. Is it exactly the same? H icon. Basically, it's exactly the same, isn't it? Okay. So, public function. And this is load icon W. This is the last one I'm putting in for now anyway. I just wanted a complete set of instructions for creating a window, and I think this is roughly about as far as we need to go. I would think H instance, it looks good. We have to treat this exactly the same as we have done with the icon, the cursor, sorry. LP icon name. Alright. And that's just your... I'm going with this one, aren't I? Yeah. Yeah, I'm okay with that. And that just goes out to a H icon. Lovely. So we have to treat this in exactly the same way because I've got a feeling that the return value is null, get extended error information. Yeah, it's exactly the same. So we're going to load the default OS system, operating system icons. Yeah, I think we'll go with that. Do I need to specify? Don't think I do. IDI small. Oh. Icon sizes, okay. They're both using icons. System uses 4 icon sizes, system small. Do, 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 do. Yeah, and the icon small. 16 by 16, yeah, it's half size. Oh god, it goes into all of this. Alright. I don't think I really need to put that in. We're looking at null mutes for default values. I think it automatically resizes. Okay. Not sure how this is going to react if I do it. Let's pop one in and find out. There's only one way to find out, isn't there? So let icon, is it? Yeah. That's going to be equal to our load icon. That one. H instance, we want null, don't we? Yeah, we'll go with a standard pointer to null. We're going to start with null and change it to null mute if we need to. And the icon name is going to be whatever we've just typed in. Ba 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 ba. Awesome. Okay. We'll do a quick fix on the unsafe block. And of course, I think we have to go to mute, don't we? Yeah. Just checking. There we go. So that should work. So we'll just pop an icon in here. And could not load the system icons. Icon. Yeah. I think that should be okay. Which would then mean we can put an icon in here. And we should be able to theoretically put it in here as well. I like theory. And that shouldn't crash or alter anything that we've done. I'm setting it up for later when I do have an icon. At the moment we don't. But hey ho. You know, certain things come in time. Yeah, it's just one of those things. So we're still getting the icon here. Still getting the icon here. Everything seems to be working correctly. I think we have basic functionality. Oh my god, we've got it. Wow. Alright, I'm just going to fiddle around with me sound cables a second. Well, that found the problem. I know where the problem is. Bugger. Oh well. Oh well, we've got sound problems. Alright, we're done. We are done. I think we're okay with this now. With me having sound problems, I'm going to have to strip down my sound system and, well, clean out all the dust. Yeah. So that is an update to the window default setup. Okay. Yeah, I'm alright with that. So I've now got 1, 2, 3 error checks in before we even get here. And any of them can panic. Fine. Alright, this is what it looks like to me. Yeah, I think I'm alright with that. But you can see now how this is extending the file and making it a little more cumbersome. Something that I am interested in is the size of this file. We're up to 167 kilobytes. If I go full error handling, that's going to go over 200 easily. I'm okay with that size so far. We've basically finished this for basic code anyway. Just checking to make sure I don't need any extra error checks down here. No, we're okay. Okay, we'll do a bonus bit because I've got a little bit of time left. What I was looking at, you might have noticed, was keyboards. How's these libs looking? Okay, we're alright. Events, please. Yeah, these aren't growing too badly. So you might have noticed when I was messing around there that we have a little bit of extra information in our Visual Studios. And I was looking at WM key down, which is value 0x0100. And what I was doing really is just messing about, seeing whether it's viable to use it or not, whether we can intercept that, do anything with it, maybe. Would need a public constant for it. That would be key down. It would be U32. And it would equal 0x000100. That's what I got from Visual Studio. Okay. What can we do with it? I think that's really the question. Let's view it out. Yeah, let's get this view going. So hopefully we can see what's going on. Nearly. God, those error messages are a bit large. Just hoping at some point I can do something about those error messages. Right. So currently, I'm attempting to intercept messages. So what would happen if our message, please, was equal to WM underscore key down? Let's print a line, and we'll just say that key down. Ooh, close. No biscuit there. All right. Is that viable? Are we allowed to go down this path? Well, code looks okay. Well, here's our window. If I press the A key, we'll use. If I hold it down, oh, it works. Huh. All right. So we are getting a key down interception. That was the A key. So that key down message has a virtual key code attached to it. We've been past translate message, which does all the translation for virtual key codes. So we should be okay. So it's got a virtual key code. Definitely. What's that going to be? That's going to be message, and it's the bottom one, a W param. Let's just try that out. So we're just testing stuff. Get you out of the way a minute. This is what I meant about having to move it every damn time to try and do something. A, 65. B is going to be, guess what? 66. Some people might recognize those two numbers. I mean, I recognise them a little bit. Let me just switch that off because it's bright to my eyes. Those virtual key codes. Well, 65, isn't that ASCII? Well, I'll tell you, before you look it up, no, it's not ASCII. It just happens to coincide with the ASCII table for the letters of the alphabet. Lowercase letters are not included within the virtual key codes. If you want to detect lowercase, then you detect the key code. If you want to detect the uppercase, then you have to detect the shift key plus the key code. So it's a little bit more complicated to use virtual key codes than it is to use an ASCII table. The other thing is, the ASCII table gets thrown away as soon as you get outside of the lowercase letters. I think numbers will be okay, like 1 to 0, well, the 10 numbers on the keyboard. I think they're okay. They might be ASCII characters. But the rest of the keyboard is giving off various things. The other thing this doesn't see is mouse input. So there must be mouse buttoned events as well. So the mouse is treated separately. That's okay. That's normal. It does tell me, oh, and there's 254 key codes, virtual key codes. Why 254? So you can make a 255 array. Because the last position in an array isn't used. In C. How do we do that in Rust? Well, what I'm thinking is just set up an array. Pop it in here into our Windows 32 event. So if we have an array of 255 bools, I guess, true or false, we should be able to detect and place into that array on this line a true. We can then access that at any time in our program to decide whether a key is actually currently being pressed down or not. But we have to also decide when do we make it false again. Well, obviously when the key isn't pressed. But we're not detecting that. Can we use a shortcut and just zero it out before polling? We can. We can set everything in the array to false and then go through the polling all of our messages, and that will refill it with all the trues. That's fair enough. I can see a few minor problems with that because of the way Windows accepts keyboard input. There's that horrible delay, so it might not work. Windows doesn't automatically repeat a key. You can tell that just by pressing a key. So if I press a key A, starts, and then it repeats. There's actually two things going on here. There is a key press, and then there is a repeat. And it works that way so that you can use it properly. That was their solution, and that solution's been around since the beginning of computers. It's not a Microsoft solution, it's just the way computers were designed originally, and it's never changed. Which means there's a gap. So we have to bear that in mind. I've got a feeling we're going to get that gap. If we use a shortcut. But we can pop what we don't want to be doing here is any logic. We can't be crunching out what is this key, this virtual key code. We can't be deciding, hey, we want to do this, it's an uppercase, it's a lowercase, etc, etc, etc. That's not for this code to decide. All it has to do is say true or false and pop it into an array. That's it. So that's what goes in on that line. I haven't decided how to treat repeat. We can use key pressed, but that only is the initial key pressed. We can use key release. I think there's a key release. To clear a flag to false. From true back to false. Which is probably the correct way to do it. So I've got a feeling that that's going to happen. But as you can see from testing, I have been able to get the codes. It's interesting because it's the first time I've ever tried to do, well, keyboard input from the Windows 32 API, and this looks too simple. And I am trying to develop the most simple code I can get my hands on. We're also getting a lot of if statements. I can remove that if statement, there's no calculation. I've got a feeling the compiler's doing that for me anyway. I'm interested to hear people's thoughts on should I do this or not. This is going beyond what we set out in our design. We only went to error handling. We're finished. We've actually finished this. Keyboard handling. If we can make this really, really simple, we could just drop it in as an extra. and get a key pressed event. Free of charge. Not a good one, but at least we'll have one. All right. Simple. Yeah, we'll just do key pressed event detection. I don't think I want to develop functionality for it at this stage. I mean, detection is probably more than I could hope for. I'm looking to possibly use some of this code now. I don't know if it's got enough functionality for me to use it. What are we looking at? WM key. Yeah, there's a key up. Oh look, it's 101. That sort of suggests that we should use it. Okay. Thinking about the logistics behind it. Again, I've never really used arrays in Rust. I've got no idea how they work at this point in time. I know how arrays work. I don't know the syntax for it all. But I've got a good idea of how it works. Okay. If I can sort out some kind of logical way of doing this that isn't going to cause a workload here, I've got to avoid putting a workload in here. And if statements become workloads if you're not careful. I think I can get rid of the if statements. Okay. I think we're going to leave it at that. And I'm going to go and check my sound system. Oh, lovely, lovely, lovely. So, what have we done today? We have done an error, a very, very basic error log. We've finally completed the default behavior for the window, even though we've just replaced the default behavior with what it originally had. There's a couple of values which I don't know how to find yet. I'll keep researching that. How to access the fact that I'm using the dark rather than the light, which is the default is light on Windows. So yeah, we've basically done that. Our error logging is very, very basic, but it will suffice. It'll catch the base errors. That's good enough for me. In the meantime, thank you for letting me know that, Mad Doctor, and I'll get off and get back to work on my setup, obviously. Take care, peeps. Get out there and have some fun.